This video is about topic 7.1, exercise 12, which talks about simplifying trig expressions using trig identities. Exercise 12 asks us to simplify this following expression. Negative sign of negative x times cosine of x times secant of x times cosecant of x times tangent of x divided by cotangent of x. It seems like a complex problem, but what we can do is we can look at each term, simplify them, and then we can combine all the simplified terms to create our fully simplified expression. I'll look at each term from left to right, top to bottom. So first we have negative sign of negative x. This is an example of our even odd identities, one of our even odd identities. It states that sine of negative theta is equal to negative sine of theta. We're going to leave cosine of x. Secant of x, cosecant of x, and cotangent of x are examples of reciprocal identities. Write all those down. Secant of theta is equal to 1 over cosine of theta. Cosecant of theta is equal to 1 over sine of theta, and cotangent of theta is equal to 1 over tangent of theta. Also, do not forget that tangent of theta is equal to sine of theta over cosine of theta. So essentially what I'm doing is I'm simplifying each expression down into using sine and cosine, and if they are, for example with this tangent, we simplify to sine of x over cosine of x. Now what we can do is that we can simplify each term and then we can multiply all of them, see if we have any like terms to cancel. So negative sign of negative x. If we look at this even odd identity, we can essentially flip the signs. So negative sign of negative x would equal to sine of x. So I'm going to write that down over here. Sine of x times cosine of x, since that is already pretty much simplified for us. Remember, secant of theta is 1 over cosine of theta, so we can write down 1 over cosine of x. Secant of x is 1 over cosecant is 1 over sine of theta, so this is 1 over sine of x. You can write tangent as sine of x over cosine of x. Finally, you can either divide this whole expression, simplified numerator, and by cotangent of x, or we can just think about this. So essentially we're dividing this. Let me write it up here. So we're dividing this whole expression divided by cotangent of x, right? So cotangent of x is 1 over x. So we're essentially dividing by 1 over tangent of x. But then since we're dividing, we're just going to multiply by tangent of x. And tangent of x is the same thing as this down here. So we're just going to repeat it again. Again, you could just simplify the numerator and then divide it by the denominator if that works for you. Now we see we have some like terms with sines and cosines, especially with the reciprocal identities. Now we can cancel. So cosine of x, sine of x, and all that's left is sine x over cosine x times sine x over cosine x. This is equal to sine squared of x over cosine squared of x. Now I'm going to write it down over here, sine squared of x over cosine squared of x. If you notice, tangent is equal to sine over cosine, so this will be equal to tangent square of x. You could also just notice that these are basically tangent, and since you're just only left with these, tangent times tangent of x is tangent square of x. So that is a simplification of this whole expression down here. All of this is equivalent to tangent squared of x. This whole question relates to if you know and how to apply your identities. Again, it looked like it was a very complex expression, but after simplifying each term, it was really easy since we were able to cancel out those like terms. And there you go.